Okay. You guys over there, are you all right? I feel like our class is now split in two, literally. We got 3 over here and 3 over there. Okay, so here we go. Chapters 1 through 5. We need to start with chapter 1. Whoa, back. On chapter 1, we talked about matter and measurement. Matter, remember, splits into 2 main groups, pure substances and mixtures. Pure substances break down into compounds and elements. Mixtures break down into homo and heterogeneous. You got that? You're good. Everything's made up by matter. Next thing I talked about was scientific notation. You need to be able to take a number and move it from decimal form to scientific notation and back again. Okay, so let's look at this first number. See if you can figure out what the scientific notation will be. I'll put the answer up in just a minute. And then do 2, 4, 3, and 4. You only need to include ones you need to. That's why I want to see how well you remember the rules. Because there is a question on this. He's going off the edge there. Okay, let's see if you got number 1 right. Okay, we get that right? Awesome. Okay, what about number 2? You got number 2 done? Actually, this should be, forgot to fix this again. You do. To put it in scientific notation, it has to be times 10 to the 0.
Yeah, but would it ever need to be in scientific notation?
If it tells you to, you put it in.
I guess. But I mean, for like a practical reason.
Practical reason, not too much, unless you have a whole bunch of numbers that you're looking at and you want to line them up. Okay, number 3 is a trick question. Let's see if you got this one right. Number 3 is a trick question. Trick question, number 3. And you would have got it wrong. If a 0 tells me how well I measured it, it has to be included in the scientific notation. If it tells me how big or how small, it's included in the times 10 to the whatever. Okay, see if you can do the bottom one. All right, so you need to be able to do this. This is one of the questions, okay? Please make sure you remember anything that tells you how well you measured needs to be included, okay? I am going to make my board is off again. Sorry, guys. I hate writing when you can't see right where you're writing it, right somewhere else. Okay, so going forward. Anybody remember this? Density is mass over volume. Good. Okay, so you need to remember that because you're going to need to be able to do a problem with it. Now, here's the hint with a problem with density. Make sure you look at the units that she wants you to have at the end because you could just take mass divided by volume here and get a density, but it's not in the volume she wants it in. So change that first and then put it into the density equation. So to change it first, we would go like this and we would divide by 1,000, whoops, try it again. We would multiply by 1,000 milliliters in 1 liter. We would get 10840 milliliters. And then we would take density is equal to mass divided by volume. Mass is 64.52 grams divided by 10,840 milliliters. And our answer, if it's bigger than 1,000 or less than 1,000th, we put in scientific notation. So what do we get?
Wait, we got rounded to 460?
Yep. 4 sig figs.
5,
5.9
5, 2,
times 10 to the
Well, there were more numbers.
3,
negative 3
maybe, yeah.
grams per milliliters. Okay, but since we had 4 significant figures here and 4 significant figures here, we give 4. Okay? All right, so be able to do that. Be able to make sure you're watching for this part right here, how to express it, because she will tell you how to express it. Change your things first and then do the mass divided by volume. Okay? All right, going forward. Isotopes, chapter 2, periodic table. There are 12 isotopes of carbon, C8 through C19. The average atomic mass of carbon is 12.011. Which isotope has the highest isotopic abundance? Shouldn't have to guess. Which one is it? C12 is right.
Is there any particular reason?
Well, if you think about it, if you add them all together,
It's closest to 12.
No, but why is that one the most abundant?
because it's there.
Because the mass number, or the atomic average mass, is based on the abundance and the mass of each one.
Or why is that amount of carbon in that isotope?
Because it's stable, 6 neutrons and 6 protons.
Look at that.
Okay. Okay. You okay to go forward? You'll get one like that. She'll pick a different isotope, a different element, but you'll get one like that. Okay. On this one, you'll be given isotopic symbols, and you need to say which ones are right and which ones are wrong. Remember, she loves to use not. That's all I've got to say. Make sure you're reading the question. You understand if you're finding one that is not correct, or you're finding one the only one that is correct. Does that make sense? Okay, so on this one right here, let's go through each one of them. Is this a possible isotope?
Yes. Doesn't the top number have to be lower than the bottom number? Other way around? Correct. No.
These actually are flipped. If you look, argon is what number on the periodic table? 18. So 18 needs to go on the bottom. The top number should be about twice the bottom number. Okay, it does not have to be the exact number on the periodic table for the top number, but should be around it. Okay, so that one is not right. What about B? Okay, look at number 22 on the periodic table. What is number 22 on the periodic table? Titanium. So that should be titanium instead of... Okay. All right, what about C?
Yes.
Everybody thinks C is okay.
Check 43. Yes.
I'm moving,
Oh, yeah, that's right.
so I have to start taking it down. We only have 5 more times in class. 6 more. Yep. Okay, next time, D. What about D? No. 10 is neon. This is actually flipped. Okay, so be careful with that. It's periodic table, nuclear. We did it both. Okay. Okay, chapter 3. We talked about ionic compounds.